Welcome to my video on comparing numbers with exponents. So it is easy to compare numbers with different exponents, but you've got to remember that they both have to be written in scientific notation in order for you to compare the exponents. So the numbers with larger exponents are always greater. For example, 10 to the power of 10 would be a 1 with 10 zeros. So do you know what that number would be? 10 billion. And 10 to the fifth would be a 1 with 5 zeros. And what number would that be? 100,000. Good. So 10 to the 10th represents a much greater number than 10 to the 5th. So let's look at the first example. We have 5 and 7/800 times 10 to the 6th, and 5 and 7/800 times 10 to the 7th. So I like to circle the exponents so I know what I'm comparing. And now I'm comparing 6 to 7. And 6 is less than, so my arrow points to the left. Okay, example number 2 says 2 and 7/10 times 10 to the 5th, so circle the 5. And 2 and 7/10 times 10 to the 4th, circle the 4. And how does 5 compare to 4? It's greater, so my arrow points to the right. Now look at the next one. They're not both written in scientific notation. So what I can do is I can change them both to standard form, which is what the 5,000 is, or I can change them both to scientific notation. So in this example, I'm going to change them both to standard form. So I'm going to write down the coefficient or the root number here, so 5.0. Time to move it 3 to the right. So 1, 2, 3. So I'm going to drop my zeros. So that, of course, would be 5,000. So how does 5,000 compare to 5,000? They are equal. Now the next one. This time I'm going to change them both to scientific notation. So I'm going to chop this. Remember, we chop where the zeros start to repeat. Write down 819. Stick the decimal in, so right here, times 10 to the, now go from where you put the decimal, 1, 2, 3, 4 to the right, so it's times 10 to the 4th. Now, how does 5 compare to 4? Good, it's greater than. And the last one, I have 1 million, so you would write a 1 with 6 zeros. Now I'm going to chop it where the zeros start to repeat. I write down my root number, which is just 1, times 10 to the. Now, because I have one whole, I'm going to start after the 1, so 1, 2, 3, 4, 5, 6 to the right, so it's times 10 to the 6th. Now they both have the same exponent. So what do you think we do if they both have the same exponent? Good, you look at the coefficient or the root number. So how does 1 compare to 1 and 1/10? Good, 1 whole is less than 1 and 1/10. Okay, let's move to the bottom here. And now we're going to look at some more examples that have the same exponents, so equal exponents. So if the exponents are equal, then we compare the coefficients, or as you'll hear me say it sometimes, the root number, starting at the left of the decimal. So start at the ones place, then we compare the tenths, hundreds, thousands, etc. So we look here, and we notice that both exponents are the same. So what we're going to do is we're going to line them up down here. So write down 1 and 89 hundredths and 1 and 3/10. Now notice they don't both have the same amount of numbers. So do you remember what I can add here so that they do? Good. By adding a 0, I do not change the value of the number. So we have 1 in 89 hundredths and 1 in 30 hundredths. So how does 1 in 89 hundredths compare? Good. It's greater than, so put a greater than symbol and my arrow points to the right. Okay, look at example 2. I circle the exponents and I notice they're both the same. So we're going to line up 3 in 26 hundredths and 3 in 29 hundredths. So how does 3 in 26 hundredths compare to 3 in 29 hundredths? Hopefully you said less than. Good, and it points to the left. And our last example, circle the exponents and we notice that they are both 6. They're both the same. So 7 in 4 hundredths and 7 in 1/10. Now, what can I do to make 7 and 1/10 have the same amount of numbers? I can drop a 0. So how does 7 and 4 hundredths compare to 7 and 10 hundredths? Good, it's less than, so my arrow points to the left. Okay, turn the page. And we're going to recap what we did here. So steps to comparing numbers in scientific notation. The first step we do is compare the exponents. If they're different, then that's our last step. We just see which one's greater, which one's less. If they are the same, then we look at the coefficients and compare those, or root number to compare. So look at the first example here. Let's circle the exponent, and we notice that they're both -3. So they're the same. Now we're going to compare the coefficients. So we have 2 in 46 hundredths and 2 in 4/10. If we tack on a 0 here, now they have the same amount of numbers after the decimal. So how does 2 in 46 hundredths compare to 2 in 40 hundredths? Good. It's greater than. So that means this number written in scientific notation is greater than that number. Okay, example number 2. Circle the exponents. And we notice they're both different, so we have to look no further. How does -9 compare to -7? Now remember, they're both negative, so it's less than because -9 is farther away from 0. So that makes this scientific notation less than, and notice less than points to the left. Okay, that concludes our notes on comparing numbers written in scientific notation. I hope you have a great day.